The space race was more than a competition. It was a clash of ideologies. The United States and the Soviet Union, locked in the Cold War, sought to prove their superiority. Their battleground? Space itself. This high-stakes race captivated the world. It pushed the boundaries of human ingenuity. Each launch was a victory. Every milestone a statement of power. The seeds of the space race were sown in the aftermath of World War II. The world was in ruins, and nations were focused on rebuilding and recovery. Amidst this backdrop, a new kind of race was beginning to take shape. Both the US and the USSR sought to harness the power of German rocket technology. German scientists, including the renowned Wernher von Braun, were pivotal in advancing rocket science. Their work on the V-2 rocket laid the foundation for future developments. Initially, the focus was on military applications, particularly the development of intercontinental ballistic missiles, or ICBMs. These powerful weapons were designed to deliver nuclear payloads across vast distances, changing the nature of global warfare. These missiles could deliver nuclear payloads across vast distances. The sheer destructive power of these weapons made them a central element of military strategy during the Cold War. They became a terrifying symbol of the Cold War. The arms race between the US and the USSR escalated, with both sides amassing vast arsenals of nuclear weapons. The threat of mutual assured destruction loomed large over the world. However, the potential of this technology extended beyond warfare. Visionary scientists and engineers began to see the possibilities for space exploration. The same rockets that could deliver destruction could also propel humanity into the cosmos. Scientists and engineers recognized the possibility of space exploration. Organizations like NASA were formed, and the focus began to shift from military applications to peaceful exploration of space. The dream of reaching for the stars was no longer just a fantasy. The dream of reaching for the stars was about to become a reality. With each successful launch, humanity took one step closer to exploring the final frontier. The dawn of the space age marked a new era of discovery and innovation, forever changing our place in the universe. On October 4, 1957, the Soviet Union launched Sputnik 1. It was a small metal sphere, but its impact was monumental. Sputnik became the first artificial satellite to orbit Earth. This event sent shockwaves across the globe. It challenged America's perceived technological dominance. The United States, caught off guard, scrambled to respond. The launch of Sputnik 1 ignited the space race, transforming the rivalry between the two superpowers into a quest for cosmic supremacy. The US government poured resources into its space program, determined to catch up. The Soviet Union continued its string of early victories. On April 12, 1961, Yuri Gagarin became the first human in space. His historic flight aboard Vostok 1 lasted 108 minutes and circled the Earth once. Gagarin's accomplishment was heralded as a triumph for the Soviet Union. It further fueled America's determination to achieve its own spacefaring milestones. The pressure was mounting on NASA, the newly formed space agency, to make its mark. Section 5. Reaching for the Moon, the Apollo Program. In 1961, President John F. Kennedy issued a bold challenge: to land a man on the moon and return him safely to Earth before the end of the decade. This ambitious goal became the driving force behind the Apollo program. It was a monumental undertaking. Thousands of engineers and scientists worked tirelessly to design and build the spacecraft and technology needed for the mission. The eyes of the world were on the United States as it embarked on this audacious endeavor. Section 6. Giant leaps in technology. The space race spurred an unprecedented era of technological innovation. Both the United States and the Soviet Union made significant advancements in rocketry, materials, science, and communications. The development of powerful launch vehicles capable of carrying heavy payloads into orbit was a direct result of the competition. Moreover, the need to communicate with spacecraft and astronauts in space led to advancements in radio technology and the development of satellite communication systems. These innovations had far-reaching applications extending beyond the realm of space exploration and transforming everyday life. Section 7. Beyond the Race, a Universe to Explore. While the space race was initially driven by Cold War rivalry, it also fostered a spirit of scientific inquiry and international collaboration. The intense competition between the United States and the Soviet Union pushed both nations to achieve remarkable feats in space exploration. This period saw the launch of the first artificial satellite, Sputnik, by the Soviet Union in 1957, followed by the United States' successful Apollo missions that landed humans on the moon in 1969. These milestones were not just about national pride, they were about pushing the boundaries of human knowledge and capability. Scientists and engineers from both sides of the Iron Curtain shared knowledge and expertise. Despite the political tensions, there was a mutual respect and a shared goal of advancing human understanding of space. This collaboration was evident in various joint missions and scientific exchanges. For instance, the Apollo-Soyuz test project in 1975 marked the first international human spaceflight mission, where American astronauts and Soviet cosmonauts docked their spacecraft in orbit and conducted joint experiments. The International Geophysical Year of 1957 to 1958, for instance, saw scientists from around the world collaborating on research projects related to Earth and space. This global scientific effort led to significant discoveries, including the confirmation of the existence of the Van Allen radiation belts and advancements in our understanding of Earth's atmosphere and magnetic field. The success of the International Geophysical Year demonstrated the power of international cooperation in achieving scientific breakthroughs. This spirit of cooperation laid the groundwork for future international collaborations in space exploration. The establishment of the European Space Agency in 1975 and the ongoing partnerships in the International Space Station program are testaments to the enduring legacy of these early collaborative efforts. Today, space agencies from around the world, including NASA, ESA, Roscosmos, and others, work together on missions that seek to explore the farthest reaches of our solar system and beyond. The space race had shown that, despite political differences, humanity could come together to achieve extraordinary things. The legacy of this era is not just in the technological advancements and scientific discoveries, but also in the spirit of collaboration and unity that it inspired. As we look to the future, the lessons learned from the space race remind us that our greatest achievements are often the result of working together towards a common goal. Section 8. A Legacy of Inspiration. The legacy of the space race extends far beyond the technological marvels it produced. It inspired generations of scientists, engineers, and dreamers. The images of astronauts walking on the moon captured the imagination of the world, showing that anything is possible with human ingenuity and determination. The space race also highlighted the importance of STEM education. It showed that investing in science, technology, engineering, and mathematics was crucial for national progress and global leadership. Section 9. The Future of Space Exploration. Today, the spirit of the space race lives on. Decades after the first humans set foot on the moon, the drive to explore the cosmos remains as strong as ever. The legacy of the space race has paved the way for modern space exploration, inspiring new generations of scientists, engineers, and dreamers to look to the stars. Nations and private companies are pushing the boundaries of space exploration, each with their own unique goals and missions. From NASA's Artemis program aiming to return humans to the moon, to SpaceX's ambitious plans for Mars colonization, the landscape of space exploration is more dynamic and diverse than ever before. With ambitious missions to Mars and beyond on the horizon, humanity stands on the brink of a new era in space exploration. These missions are not just about reaching new destinations, but also about developing the technologies and knowledge needed to sustain human life in the harsh environment of space. The International Space Station, a testament to international cooperation, continues to serve as a platform for scientific research and human spaceflight. It has been orbiting Earth for over 2 decades, providing invaluable data and experience that will be crucial for future long-duration missions to the Moon, Mars, and beyond. The quest to explore the cosmos continues to inspire and challenge us. Each mission, whether successful or not, teaches us more about the universe and our place in it. The challenges of human spaceflight, from radiation exposure to the psychological effects of long-term isolation, push the boundaries of our knowledge and capabilities. As we look to the future, the lessons learned during the space race will continue to guide us. The determination, innovation, and collaboration that characterized that era are more important than ever as we tackle the complex challenges of modern space exploration, reminding us of the power of human ambition, ingenuity, and the importance of international collaboration. The future of space exploration will be shaped by our ability to work together, share knowledge, and push the boundaries of what is possible. As we venture further into the cosmos, we carry with us the hopes and dreams of all humanity,